Okay. I think this is going to work. I'm going to be super angry if it doesn't. Okay. Did you guys get all those?
Yes.
Oh.
Sorry.
No problem.
Just my spacing was really bad.
Go ahead.
Okay, we're good? All right. Let's go ahead and do this. The first one was CO3 with a 2 minus charge. So now I'm going to do this one. Maybe then you guys don't have to worry about, you figure it out. Okay. So carbon has 4 electrons, right?
You forgot the minus one.
Oh, God. Okay, 4 electrons. And then oxygen is in group what? Group 16, so it has 6. So 6 times 3 is 18. And 2 more. So all of these numbers are coming from their group number. Are you guys okay with that so far?
Okay, I need a little, like, I don't know, a briefer on the -2.
Sure. If it means you have a -2, electrons have a negative charge.
Okay.
So it means you have 2 more negative charges.
Okay.
So when we're adding up electrons, I need to include the 2 more negative charges.
Okay.
Does that make sense?
Yes.
Okay. So I have 24 electrons total. Okay. Carbon goes in the middle. 3 oxygens around it. How many did I use up? 6. I have 18 left. I think that's right, right? Yeah. So I'm going to put the 18 around the oxygens first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I used up all of my electrons, but do you notice that carbon is electron deficient and it's not supposed to be?
Why? Does everything not, is everything
Well, we have
not supposed to be electron deficient?
Well, we have hydrogen and helium. Those can be electron deficient. Those can have 2.
Okay.
And then we had boron, beryllium, aluminum, and magnesium. Those ones were okay to be electron deficient.
Okay.
And then anything in period 3 through period 7, they could have more than 8. They were okay.
Okay.
So we're gonna come across all of these examples. That's why those are specifically up there. Okay. Yeah, so the problem with this is that carbon doesn't have 8, so I need to create a double bond. So I'm going to scoot 2. Okay. It creates resonance. Now let me just give you a hint on the exam. There are no pictures of brackets and then charges. Okay? So the question for this is, what is the shape? It doesn't say how many resonance structures does it have. It doesn't say, do you need to put it in brackets? That's like your AX. Okay, so central atom, 3 bonded. So trigonal planar, flat as a pancake. Now, I don't think that polarity's on there, but if you looked at it, is it polar or nonpolar? Flat as a pancake, all evenly spaced out. Nonpolar. Okay?
What does polar mean?
Polar means like there's an uneven pull of electrons.
Okay.
So we're going to come across that. Okay? You okay over there? You just keep balancing, brother. Make sure they all equal. All right. CO2 is the next one. Carbon has 4. Oxygen has 6 plus 2, or I'm sorry, 6 times 2. That's 12. I have 16 electrons. What goes in the middle? Carbon, oxygen, oxygen. Okay, I used up 4 electrons. I now have 12 left. Where do I put them? Do I put them on carbon first or the oxygens? Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I used up all of them, and again, carbon doesn't have enough. So what? Okay, I could do double bonds on each side or triple, right? So let's say that we just keep with the double bonds. It has resonance. We're not going to worry about arrows. What is the shape of this? AX2, yep, linear. And because these are the same elements pulling on the central atom, this is going to be nonpolar.
But you could do triple bonds.
I could do a triple and a single, yeah. And you guys saw this. I mean, there's a reason why these were on your exam, and this is why we're doing these, because they're on your final. Okay? Let's do like 3 easy, fast ones. I'm going to, actually, is it okay if I skip in that order? Do you guys have room, or does it matter? Okay, let's do CH4. So if you could skip down a little in your list, CH4, carbon's in group 14. So how many valence electrons does it have? 4. Okay, hydrogen has 1. 1 times 4, that's another 4. 8 total. What goes in the center? Carbon, 4 hydrogens. How many did I use up in the bonds?
8.
2, 4, 6, 8. I have none left. Is it okay if hydrogen only has 2 around it? Yes, it's an exception, right? So, nothing left. Central atom? Yeah, AX4 is tetrahedral. Polar or nonpolar? Nonpolar. 4 of the same pulling on the central atom. Let's do NH3. NH3. So aren't you guys glad you came? Okay, NH3. Nitrogen with group 15, that's 5. Plus 3 hydrogens at 1 each, right? You guys are still okay with me about counting the electrons, right? Okay, we're okay? All right. What's in the middle? Nitrogen, 3 hydrogens. How many did I use up in the bonds? 6. 2 left, yeah, a lone pair on the center, right? I didn't put them around hydrogen because what's the maximum number hydrogen can have? 2. So it had to go on the center. AX3, what? E. So E is a pair. But
just E because it's a pair.
Yeah, E because it's a pair. Exactly.
If
AX.
there was like 4 dots, then it would be 2.
Yes, that's exactly right. Okay, so what's the shape of it? Trigonal? Trigonopyramidal, right? And it's going to be polar because there is a lone, it looks like a pyramid. It looks like a little pyramid with a lone pair at the top. Okay? Anything with 1 lone pair on the center is always polar. H2O. Okay? Hydrogen, that's 2 of them, plus 6. That's 8. What's in the middle? Yep, sorry. Okay. How many did I use up? 4. I have 4 left. Where do they go? What's the maximum hydrogen can have? 2. So,
It goes on the oxygen.
goes on the oxygen. You see why we're doing this, right? Central atom, yes. AX2, what?
E2.
E2, its shape is bent, and anything that's bent is always what? Polar. Did you finish? Do you need help? Okay, hold on 1 second. All right, you guys have BCl3, and what's the other one? An NO3 with a -1 charge? Is that right? Oh, you guys have SO3 as well?
Yeah.
Oh, yeah.
There's 3.
Okay, so do BCl3. Can you guys do that super fast? Yeah, that's right. That one's right. Okay, so you have 2 NAs over here. Look, you have 3 NAs over here. You see what I'm talking about? 2 S's, 4 S's, okay. 3 O's, 6 O's, 2 I's. So it looks like your NAs don't match, right? And then S's don't match either, which is fine, because we could probably take care of that. Oxygen is only in one place. Okay, let's get 2 in front of here. Because changes, if we do that, that changes that to 4. Okay, and then it changes our sulfurs to 4, so that matches up. Our oxygens, now I have 6. And my iodines, that doesn't match. What if I put, what should I put in front of here to make it 2 I's? I have 2 I's over here, but only 1 here. So what coefficient goes there? What do you think? It has to be equal. Well, it needs another one, but what's the coefficient? So like, if that has 2 over here, what number would I put in front of here that I can multiply by that and it would be 2? So, that changes my i's. Now how many NAs do I have? 2 here. And how many here? This number goes to both of those numbers. So 2 and 2, right? Now it's all balanced. This one, you want to keep together your polyatomics, okay? So Ca, OH, H, and PO4. That's how I want you to try to do that one. Okay, so BCl3, this is a weirdo one. Boron is in group 13, so 3 plus 7 times 3, that's 21, 24 electrons. Okay, boron in the middle, 3 chlorines. 6 used up, 18 left. You guys should have distributed those around the chlorines. Do you guys do that? You ran out. That's it though. Why am I not going to make a double bond?
Because boron's an exception.
Boron's an exception. It can have less than 8. AX3, trigonoplanar, flat as a pancake, nonpolar. Okay? Okay, let's go back up. SO3 with a 2 minus charge. SO3 with a 2 minus charge. We're almost done with that molecular geometry for the whole section, so that's good. Okay? All right. Do you guys want to do this and I'll do it up here, or what do you want to do? You guys want to try it yourself?
Yeah.
Okay.
Never mind.
Okay, I'll do it up here, and then whenever you guys need to look up here, we'll do it that way.
I'm good.
Okay. Plus 18. Are we keeping things together? So 1 CA, oh yeah, 3, okay. 2, right? And then 3, right? Okay, so what should we put in front here to balance our PO4s? 2 on this side and 1 on that side. Yeah, good. Okay. That changes your hydrogens. Well, 2 in front, but it's distributed. 2 times 3 is what? Okay, so keep balancing. Now we have to balance. You have to balance your hydrogens and your hydroxides and your calciums. What could we do? What could you put in front of there instead of a 1? 3 on this side and 1 over here. Yep, and keep them. Change your distribution. Okay. Do you guys get that or no?
Yeah.
Kalia, did you get the 2 electron thing?
Yeah.
Okay, but you didn't. Now you said yeah, and now it makes me seem like you didn't get anything else.
Okay, I gave it a double bond for one of them. I gave one of the O's and the S a double bond, and then I put the 2 extra ones on the S. But so I just okay.
I think it was the.
But
Yes.
there's 20 though.
Yeah.
26 total. See, okay, well, wait, but doesn't S need? Oh, but you give it. Never mind. We're good.
We're okay?
Yeah.
Okay. You guys are gonna come across this on the final and be like, "Ooh, I know this one." Okay, what's the last one? NO3 with a -1 charge. Okay, let's do it.
Wait, I have a question.
Yes.
If they
have like a charge, do you still have to write the bracket with the charge outside of it? or
You
whatever?
do, so at this point, you don't have to worry about that because there is no option for a picture like that
Okay.
because it just asks you the shape.
Okay.
So it won't say like, does it need brackets or anything like that, or double arrows. It'll just say, what shape is SO3 with a 2 minus charge? Okay? All right, NO3, so N is 5, 6 times 3 is 18, plus 1, what was that, 24? Nitrogen in the middle, 3 oxygens, 6 used up, 18 left. Okay. What do we need to do?
Nothing.
Are you sure?
Oh.
So what?
I hate those.
So nitrogen needs 8, right? It's not an exception. So I need to scoot 2. Okay? So now all oxygens have 8. This is a rotating double bond. Obviously, it's not even going to ask for that. Okay? AX3, trigonoplanar, nonpolar. Okay, so if you're having a hard time with this, you should re-practice this right before the exam with your notes. You need to redo the exact same ones.
Okay.
Okay? All right. Well, that was like another 10 bajillion questions, so we're good. All right, so we're going to do naming on Thursday. So what are we going to do tomorrow?
What's that?
Okay. Hold on a second. Let me pause this.